Hello all, welcome to Microprocessors and Microcontrollers lecture session. So today we are going to see about 8086 microprocessor, that is unit 1, and first we are going to discuss about the topic architecture of 8086. Before we are entering into the topic, we are going to just discuss about some of the features of 8086 microprocessors. So we have already been discussed that 8086 is a 16-bit microprocessor. So 8086 is a 16-bit microprocessor because it can perform 16-bit operation, so that the size of ALU is 16-bit, and it has 16-bit data bus. It has 20-bit address bus, so that it can access up to 1 MB of memory location, and it has multiplexed address and data bus. So multiplexed address and data bus, so which means a single bus la address will travel agum, at the same time data will travel agum. Okay, then it can support up to 64 IO ports, and it provide 14 16-bit registers, and range of clock pulse is 5 MHz to 10 MHz. Next we are going to discuss about the important topic, internal architecture of 8086. So 8086 employs parallel processing. So parallel processing, which means it can perform more than one operation at a time. So 8086 CPU has two parts which operate at the same time. So 8086 can split out into, the architecture of 8086 can split out into two different units: bus interfacing unit and execution unit. So this is the general architecture of 8086 microprocessor. So 8086 microprocessor splitted into two units: bus interfacing unit, BIU stands for bus interfacing unit, and EU execution unit, EU stands for execution unit. In bus interfacing unit there are four different blocks. First, this is adder, and here we have segment registers, and this is instruction queue, and here is memory interfacing unit. So bus interfacing unit can be constructed with four different units: adder, segment registers, instruction queue, and memory interfacing. Next, execution unit. So execution unit divided as general purpose registers, and this is these four A, B, C, D. These four are called general purpose register, and stack pointer and base pointer, these two are called as base registers. And next to source index and destination index, these two are called index registers. And here we have arithmetic and logical unit and flag register, instruction decoder, and control system. So totally execution unit can be divided into 7 different units: general purpose, base registers 2, source and destination index registers 3, arithmetic and logical unit 4th block, flag register block number 5, instruction decoder and 6th one, and finally control system. So 7 different blocks. So 8086 execution unit divided into 7 different blocks. So here main units of execution unit: instruction decoder, control system, arithmetic and logical unit, general purpose register, flag register, pointer register, and index register. Instruction decoder. So in general, instruction decoder translates instruction fetched from memory into series of actions which execution unit carries out. Control system. Generally, control system provides the timing and control signals to perform internal operation of the microprocessor. And arithmetic and logical unit. Execution unit has 16-bit ALU so that it can perform 16-bit arithmetic and logical operations. So arithmetic operation means addition, subtraction, multiplication, division, increment, decrement, like that. And also it can perform logical operation like AND operation, OR operation, XOR, XNOR, complement, shifting, rotating operations likewise. Next, some of the general purpose registers in 8086. So 8086 has 8-bit registers: AH, AL, BH, BL, CH, CL, DH and DL. Generally, it can be individually used for storing 8-bit information number, and register AL is otherwise called as accumulator. If we are combining two registers, then it becomes 16-bit register. If we are combining two 8-bit register, then it becomes one 16-bit register. For example, if we are combining AL and AH, then it becomes AX. So AL is 8-bit register, AH is 8-bit register. If we are combining two 8-bit register, then it becomes 16-bit register. So AX is 16-bit register. If we are combining BL and BH, then it becomes BX. If we are combining CH and CL, then it becomes CX. If we are combining DH and DL, then it becomes DX. Thank you. In next class, we will discuss about a bus interfacing unit.